Okay, good morning, and hopefully everybody had a good weekend. Um, so yeah, we're gonna do a few more exercises in chapter 14, and I think we're right on track in the syllabus here. Yeah, so I sent you guys a couple emails this weekend about the midterms. Um, so those are graded, and you can see your grades, and I emailed you solutions. And then I updated your homework grades or your assignment grades as well, up to everything except for these ones because those are due today. So these ones are due today, just like the syllabus. And it looks like we'll do these two this week, Monday and Wednesday, and those will be due next Monday. Yeah, and so we're up to date, and so all the due dates in the syllabus should now be accurate for the rest of the assignments. Okay, including the final, which is just due by email the Monday of finals week, so you don't have to, there's no timed exam or anything. But today we're gonna do example 14.7, 14.8. So this one, and you can open up the example 14.7, 14.8 Word document. Okay, looks like that. And the first one we're going to need is the pharmaceutical sales. Okay, so you can open up that one right there. Looks like this. Okay, and so let me introduce, or let me read the little description. So we're going to do some more types of forecasting or exponential smoothing this morning. Okay, so this is in our textbook. This is example 14.7. This is forecasting quarterly sales at a pharmaceutical company. So the file pharmaceutical sales contains quarterly sales data for a large pharmaceutical company for the first quarter of 1998 through the fourth quarter of 2007 of millions of dollars. The time series plot here and the one we're going to make shows a fairly consistent upward trend with with a relatively small amount of noise, and so can Holt's method be used to provide a reasonable, accurate forecast of this series? So Holt's method so we learned about simple exponential smoothing last time on Wednesday. That was the last exercise where we used alpha to apply different amounts of weight on the last observation, right? And so what this is a more, I mean, just another type of exponential smoothing which would apply a technique if you have a trend. And so if you have if you look at your data and you see kind of an upward trend or a downward trend, that see how this data kind of fluctuates, but it's clearly going up over time. And so we could use, so this essentially incorporates the features of both like a linear trend line and exponential smoothing. So we can use it, we can look and see that this is a trend, right? It's trending upwards. So we're going to use that concept, and we're going to use an alpha to give more weight to whatever we think for the last observation. So this is simple exponential smoothing and using a trend. And so if you see a trend in your data, whether it's upward or downward, like we do here, you can use this type, Holt's method, which is a type of exponential smoothing that incorporates a trend. So if we look at the data, let's see, well, it's going to look like this because this is what our graph should look like. But if we see that our data has a trend, we can use this type of model to predict it. Okay, so example 4. So there's the first type of exponential smoothing we're going to look at here is Holt's exponential smoothing or Holt's method. All right, there's a little video that explains more on that if you want to take a look at that. So this is example 14.7, forecasting quarterly sales at a pharmaceutical company. So open up the pharmaceutical sales Excel file. Okay, so first thing we'll do is look at the data. So I told you we're going to use something that incorporates a trend. And so let's make a time plot and see if we see that trend in our data. Okay, so this is the idea here. So we got the data. Um, we're going to use, so because Holt's method is something a little more advanced than just what's included in your typical student version of Excel or Office, you can't really do it without an add-in. So I had to do it in a separate program, and I just kind of put the forecast in here. So we're not going to actually do the Holtz method because you can't do it without purchasing an add-in for Excel, which I don't want to make you do. But you can see the idea. So this is something where I'm sure you can find some other software. The software I use to do this when I teach forecasting classes is called R or R Studio. Okay, so I put that in the chat. You don't have to go to it, or just if you're interested in time series analysis or forecasting, it's a free type of software you can use for all types of that, and that's how I got these forecasts. You don't have to do it for this class, but just if you were interested in any of these types of time series analysis or forecasting, I teach a class on that sometimes, and so you can reach out to me if you wanted some more information, because there's some free software you can use. And if you're doing a project or some kind of thesis, might be of interest. But if not, you don't have to do it. So um, first thing we'll do here is make a time plot. So step one is to make a time plot. Okay, so let's select all the data. Okay, so you can see here before we do that. So we have data from quarter 1, 2005 to quarter 14. I mean, quarter 4, 2014. There's only 4 quarters. And we're trying to predict the next 2 years, which is essentially the next 4 quarters. So each quarter is 3 months. All right, so we're using that data. We have those 40 observations to try to predict the next 8 quarters. Okay, so let's make a time plot and see that trend that we're looking at. Okay, so select all the A and B column. All right, so select A1 to B49. Okay, including these blank things because that's what we're going to put our predictions on the graph later. All right, so A1 to B49, and let's go ahead and just make a simple plot. So insert, try recommended charts, and not what we want. We want the line chart, this one. There it is. Okay, so you can just choose a simple line chart like that. So okay, so the one I chose, this one was just when your data is selected under insert, and see that one there. This is just insert line or area chart. Just choose the first one. All right, and that'll do it. All right, so choose that one, and it should look something like this. Oh, that's yeah, that's something. All right, you get Timothy. That's on you. Okay, so here's our graph, and you can see that we do have an upward trend, right? So do we get this graph where it shows here's the sales data, and it's going up over time. So we're going to incorporate um, a, a type of exponential smoothing that incorporates this upward trend. All right, and so we've seen that the data kind of goes up over time. We're going to expect that to continue unless something changes, right? So given what's happened in all this data, uh, there's an upward trend. And so let's use that upward trend to get the best predictor or model of our data that we can. So the reason why we're using the Holtz method is because we have a trend, and in fact, it's an upward trend over time. So we're going to use that concept, and our forecast is going to be something that keeps going up, right? Because we expect this upward trend to continue. Okay. All right, let's go ahead so let's do a few things to this graph before we do the analysis. So let's just, I like to hit the plus sign, and let's remove the chart title, and let's add axes titles. Okay, and we know that this is sales. Okay, and we know that this is the quarter. All right. So again, if you wanted to do it from the drop-down menu, you would click on your chart, and you would click on Chart Design. And if you're using a Mac, you would hit Add Chart Element. You can take away the chart title, and you can add axes titles right there, and just type in your thing. So for time series, this is the time, the quarter, and this is the sales. All right. So there's our time chart. We see the trend. We're going to use that concept to see how Holt's method does a better job than the simple exponential smoothing. Okay. Step 2. Step 2. Um, let's do our simple exponential smoothing with an alpha equals 0.9, similar to what we did on Wednesday. And let's look at that one. And then we're going to compare it to the Holt's method. And we're going to see that the Holt's method does a better job because it uses the concept of incorporating the trend. And so if you see data with the trend, and you want to use exponential smoothing, then you want to use the Beth method that captures that trend, which in this case is going to be Holt's method. So, but first let's compare it to the previous, so we see the difference here. All right, so step 2 is using an alpha equals 0.9. Let's generate an exponential smoothing process, including the forecast for the next quarter. Okay, so there should be a little section here, alpha equals 0.9. That's where we're going to put our forecast, okay? So what you want to do is click on data, and we're going to use data analysis. So hopefully everyone we've been using it for a few weeks. So I believe everyone has data analysis. If you don't, let me know. But click on data analysis, and we're doing exponential smoothing. There it is. Click on that, hit OK. Our input range is all of the quarter, so click on that, and let's choose I'm sorry, that's not the right. Okay, so we want to choose the sales data. So let me go back. All right, so input range, hit that button, is the B column. Okay, B1 to B41. Hit that to choose that. The damping factor, because we want an alpha of 0.9, so the damping factor is by definition 1 minus alpha. So 1 minus 0.9 is 0.1. Click on the labels box, and the output range is going to be, hit that button, C2 to C42. Okay, so there's the exponential smoothing parameters that you want to double check. So the input range should be B1 to B41. The damping factor should be 0.1. Click on the labels box, and the output range is C2 to C42. Okay, so we got that. Hit OK. And we'll format this a little bit, but we should get that exponential smoothing process right there in that column. Okay, so everyone good so far? Did we get that? We get those calculations there in the C column?
Yes.
Okay, first thing, all right, let's delete this thing, the little hashtag NA, that we don't need that. Okay, second thing, let's format the C column. Click on the C column, and let's format it just to be currency like the sales. All right, so click on the whole C column and then insert, not insert, sorry, Home tab. Okay, so click the C column, Home tab, um, insert, or Home tab, format cells, currency. And we can just do 0 decimals with the dollar sign. Hit OK. All right, so again, click on the C column. Under Home tab, click on the Format drop-down menu. Choose Format Cells, and you want to change the category to currency. I did 0 decimals with the dollar sign symbol, and just hit OK, and that should do it. Okay, so see how it puts the values in the same currency terms. So these are our sales, actual sales, and these are our predictions. With the exponential smoothing, alpha equals 0.9. Okay, and then last thing, let's apply our forecast to the next period. So if you go down to um, C41, you should have a value there. Okay, and we want to get the forecast for the next quarter, so just go ahead and click on C41 and just grab the bottom right corner and drag it down one, like that. Okay, and so our alpha equals 0.9 prediction for the next quarter in cell C42, right? If you click on it, it should do 0.9 times B41 plus 0.1 times C41. So alpha times the last observation plus 1 minus alpha times the last forecast. So double check right here that your value in C42 is this, 8,234. All right. Okay. So we got that. Okay. Step 3 is let's calculate the absolute percentage errors for the simple exponential smoothing that we just did, and we'll compare them to the Holtz method. Okay. So actually first let's just format. I know the D column needs to be percentages. Maybe it's already in percentages. Actually, it is. Okay. All right. So let's calculate the first APE in D3. So the formula, we've done this a bunch of times, equals ABS. Okay. Double parenthesis, B3 minus. Okay. There we go. So equals absolute value. B3 minus C3 divided by B3. Okay, so the absolute value of the sales minus the prediction divided by the actual, so equals ABS, double parentheses B3 minus C3 divided by B3. Okay, then close the parentheses, and you should get 7.32% for the first one. And all we need to do is click on that one, D3, drag it down all the way to there, all right, to D41 to get all those APs. And then what we're going to do is right here where I put a little space that says the MAPE in blue for the simple exponential smoothing that we're doing. Okay, we're going to get the average and then compare it to the one for the Holtz method. All right, so got those, and then go ahead and go right here, D51, and the formula is equals average. Okay, average D3 to D41. Okay, and so we should get the value you want to look at here is if you're following along, you got in D51, the value should be 4.62%. Okay, did we get that? Right. Okay, so we looked at the data. We know how to do it as simple exponential smoothing, which we did. We did that and got the MAP. Now we're going to do is compare what we've learned, or just a simple one with the Holtz linear trend. All right, so which method has the lower MAP, and what should be our forecast? And then what we could do is we can put a graph of all of them together and see kind of the difference. So again, we're not going to we can't do the Holtz method in Excel without a purchased add-in, so I'm not going to make you do that. But I got the values here from a Holtz method using that other software, the R squared. And so well, actually it's closer than we probably think, but based on the historical data, this was the MAPE for just the simple exponential smoothing, and this was the MAPE for Holtz method. All right, so it's actually pretty close, but this one's a little bit lower. So that would mean, according to this analysis, that the Holtz method captured the historical data better, right? It has a lower error, so we'd go ahead and use the Holtz method. So this was the MAPE for all the simple exponential smoothing values that we got here. And this was the MAPE for the Holtz method, which I did in an outside software. Okay, and then these are the forecasts for the Holtz method. So what I'd like to do now is kind of let's see if we can add the two forecasting methods to the graph and kind of see the difference. So let's try that. What I want to do is let's see if we can add them to our graph. Okay, so let's see. Click on the graph, right click it, and there should be an option for select data. Okay, and we've done this I think once or twice. See where it says legend entries series. Click on add, and the series name for the first one, click on that, is going to be just um, C1. Okay, and the values, so it says series values, click on that, and the values would be C2 to C49. Okay, so C2 to C49. All right, all the C column data, including the blank ones. All right, and then if you hit that button, okay, so the series name is C1 and the series values are C2 to C49. Hit OK and hit OK. Okay, so that's one of them. Now we're going to do the Holtz method, but see how it, actually, one more thing, or if you click on the chart, first of all, did that work? Were we able to get the second series added to the chart? So you should have a blue line and a red line. So I believe the red line is the forecast and the blue line is the old data. Okay. All right. Well, okay. So if there's any problems adding that data, then let me know and I can do it again. But we're going to now add the Holtz method column, and then a legend, and we can see them all together. So next thing is let's add another series. Okay. So right click the chart again, select data. Okay. Do another one. So add again. Hit the add button. Series name now is Holtz method. So just E1. Click on that. In the series values, click on this button and just select all this blank stuff and the forecasts. All right, so we'll select E2 to E49 and then hit that button. So yeah, series name is E1 and the series values are E2 to E49, and hit the OK button and hit the OK button. And if you got this, you're going to have the three things together. And then last thing is I want to add a legend so we can see what these colors are. So click on the chart and then click on the plus sign and click on legend. Yeah, sure. That looks good. I'll make that a little bigger. Okay, and to do the legend from Mac version or from drop down, click on the chart, click on chart design, and where it says add chart element, there should be the option for legend. All right, so you can get to it that way. Okay, so this is basically the graph we're looking for. So it's a really nice descriptive graph that shows the blue line, which is the actual sales data, the red line, which is the simple exponential smoothing forecast, including the 1 month, and then the Holtz method. So see how the Holtz method incorporates the trend from the data. So see how our forecast, the green line for the next 2 years or 8 quarters, kind of keeps we don't know what these fluctuations are hard to predict, but what's not hard to predict, given what we've seen, is that the trend's going to continue upward. So it basically the green line continues the forecast to be an upward trend, and so sales data, simple exponential smoothing, and then the Holtz method forecasts for the next 4 quarters. And if you were able to do this, you can see how the different things kind of look on the graph. Okay, so any problems getting this graph? Okay, well, so that we have another exercise to do, but that's all right. So that completes this one. So everyone's got this. We're done here. Okay. All right. So if you got this final graph, then that's the final step for this one. All right. And so pharmaceutical sales is this is the completed one for example 14.7. Okay, so that one's going to go there. And we still have 14.8 to do. So again, you can either post two separate discussion posts, or you can reply to your post and post one of them to the original and post one of them to your reply. So they're both going to go in here once we're done. Okay, so 14.7's done. Now let's do 14.8. Okay, so the next one, we're going to be forecasting quarterly soft drink sales, and we're going to learn about a different technique, which is called Winters. All right, these are the names are the last name of the guy who, or the uh, could be females. I don't know who Holt or Winters are. The last name of the person who I guess got credit for this type of method. So Holt did get created or got credit for the trend one, and then Winters, last name is Winters or Winter, got credit for this one, which is going to incorporate seasonal aspects. Okay, so seasonal aspects are going to be when like the sales for your particular company or service are different depending on the time of year. So like if it's ice cream or cold drinks, you might expect that There's more sales in the hotter times because less people want ice cream or cold drinks in the winter. Or if it's something like skiing or snowboarding, you're going to have, when you forecast your sales, right, all your sales are going to be in the winter, and no one's going to snowboard or ski in the summer because there's no snow, right? So stuff like that. Okay, so for this one, example 14.7, 14.8, you want to open up the soft drink sales, this one. All right, so this is the next file. Okay, so I'm going to close this one. Okay, so example 14.8, forecasting quarterly soft drink sales. So you want to have that soft drink sales Excel file open. Okay, this one, and then let me see if I can find the description for this one. Okay, so again, we're going to use this different method, another type of exponential smoothing. This time we incorporate seasonality, all right? And so we'll kind of see what that looks like in the data. But see it, so we'll make a plot, but here's the uh, description. So forecasting quarterly soft drink sales. So the data in soft drink sales represent quarterly sales in millions of dollars for a large soft drink company from quarter one of 92 to quarter one of 2007. As we might expect, there's been an upward trend in sales during this period, and there's also a fairly regular seasonal pattern that you can see in the figure. So sales in warmer quarters 2 and 3 are consistently higher than in cooler quarters 1 and 4. And how well can Winter's method track this upward trend and seasonal pattern? So Winter's method is going to use the trend and the seasonal pattern. So see how this data is going up over time, but also, all right, it goes higher in the warmer months and lower in the winter. So every year it fluctuates around the trend where it's warmer, more sales, colder, less sales, warmer, more sales. So see how this pattern, right? It's not perfect, but it's pretty easy, pretty consistent, and we can expect this to continue. Where basically, if you look at this data, and it's not always going to be this nice, but clearly you can see here that if we're making a forecast for the coming years. What we'd expect, given the historical data, is that it's going to keep going up, and it's going to keep this seasonal pattern. So we're going to keep this behavior going, and we're going to keep increasing it up. So see, that's what we're trying to do is all the things that are somewhat predictable or consistent in the historical data, which in this case are the trend, the upward trend, and the seasonal behavior. Okay, so if we can use that to make our forecast, that's going to make it a lot easier. So we can see that we're going to keep this data going up, and we're going to keep it following the seasonal pattern, where in the summer months sales are higher, and in the colder months, the winter months, sales are lower. Okay, and then so Winter's method, there's a nice little video there if you want to take a look at that, give you some more background on there. So example 14.8. Okay, so we got the soft drink sales file open. Oops, which looks like this. Okay, so we got our data. We're gonna do the simple exponential smoothing, and then we're gonna compare it to the Holtz-Winters. So again, you can't do the Holtz-Winters method in Excel without buying an add-in. Okay, so we're not going to do that, but I did it in that other software, the RStudio. And so we got the values. We got that mean absolute percentage error. So we're going to compare, we're going to do what we can and then see how much better this one does, because this one's going to both capture the trend and the seasonal pattern, right? So we'll see the big difference, especially if you have a seasonal pattern where this can make a huge difference in your modeling and your forecasts. Okay. Okay. Example 14.8, forecasting quarterly soft drink sales. So soft drink sales fell. So step one, let's just make a time plot of sales over time. All right, and then we'll add the other things to it later, but let's first just make the time plot so we can actually see this, so you can see the seasonal pattern and the trend in your data. Okay, so first just select all the data like this, or all the A and B columns, sorry. Okay, so go ahead and select A1 to B70. Okay, A1 to B70, so that includes all the actual data and the 4 months, or the 4 quarters, or the 8 quarters we're trying to forecast. So this, everything up to 62 is actual data, and the next 8 observations are the next 4 quarters for the first year, 2015, and the next year, 2016, 2017, that we're trying to predict. So just select A1 to B70, then insert, and we want the line chart again. So this one, line, this is the first one, the line chart. Okay, there it is. All right, so you can see there. Here's our sales data. Here's the quarter, and what do we see? We see that this data is there's a clear upward trend, right? So on average, it keeps going up every quarter, and you can see the seasonal behavior, right? Goes up and when it's warm, goes down. Goes up when it's warm, goes down. All right, so we can expect this, both two things. We can expect the trend to continue, all right, and we can expect the seasonal pattern to continue, right? So that's what we've seen in all the data for 15 years, and so why not assume it's going to keep doing that for the next couple of years? Okay, so click on the chart and let's do the normal formatting. So click on the plus sign. Okay, and you can uncheck the chart title and you can check axes titles. All right, and this is sales. And this is quarter. Okay, and then one more time, if you wanted to do it this way, click on the chart design, add chart element, and you can take away the chart title there, and you can add the axes titles there. All right, so either way. Sure. So step two is now let's do a simple exponential smoothing with this data. All right, then step three is we'll calculate the MAPE. First calculating the APE, and then, well, let's do that first. All right, here we go. Okay, so we're gonna do by using data analysis, simple exponential smoothing with the alpha equals 0.9, and then we're going to compare that to the Holtz-Winters. So the Holtz-Winters is going to be better because it incorporates both the upward trend and the seasonal predictions. So data, and then data analysis. And again, we're doing exponential smoothing. There it is. Hit OK. The input range is it already set? B1? No, not set. Okay, we gotta fix this. So input range, click on that button. Input range is B1 B1 to B62. Okay, hit that. Damping factor is 0.1, that's good. And the labels box should be checked. In the output range, we need to extend that, so hit that button. Should be C2 to C63. Okay, input range is B1 to B62. Damping factor is 0.1. Your labels box is checked, and your output range is C2 to C63. Okay, and we can hit the OK button, and we should get our our simple exponential smoothing here. We should get these calculations when we do that. Yeah. Okay. All right. Everyone good? We got this.
I didn't get that.
You didn't get this part?
No, I didn't. I was
Okay.
having some trouble trying to open it up, but I had to just re-download it.
You mean the data analysis?
Yeah.
Oh, okay, but you got it now?
Yeah, I have it now.
All right, so let's do that again then. All right, so you got your graph, and then the next thing we're going to do is calculate the exponential smoothing. Okay, so we got your file here, and then let's click on data and data analysis. Okay, and exponential smoothing, and hit OK. Okay, and so I think I have it selected. Yeah. So your input range, you want to select B1 to B62. Your damping factor should be 0.1. Labels box should be checked, and your output range, you want to select C2 to C63. Okay, so when you open up, or when you have everything in the box, it should look like this. Input range B1 to B62. Damping factor 0.1. That labels box is checked, and then this should say C2 to C63. Okay, we got that.
Yes.
All right.
Yes, got that.
And, yeah. All right. Hit the OK button, and that should do it.
Yes, it did it, but I got like different numbers.
Hmm. Well, so let's click on C4, and let's look at the formula. So does your formula look like this? In C4 equals 0.9 times B3 plus
No,
0.
it went down to C. I think I selected the range wrong because I didn't. It's at C4 right now.
Oh, okay. Well, let's see if we can fix it. So let's see. All right, so hit the back button. Let's start again. All right, so delete all that or just hit the back button. And so you got this, the C column's blank. And let's try hitting the, so data
Yep.
analysis, exponential smoothing. Okay. And so let's make sure the ranges are correct. So it should be B1 to B62. That's 0.1 and that's checked. And this should be C2 to C63. So if you double check those input range and the output range, that should do it.
It said B1.
Yeah, B1.
Oh, okay, that's why. B1, B2, and then C2,
Yes, C2 to C63.
C63. Okay, I don't know. All right, I think I got the right ones. I've checked everything. It looks good.
All right, so let's hit OK again, and then let's see if we do your numbers look similar.
Yes.
All
No,
right.
it looks. Thank you.
Yep, you're welcome. Okay, so we got our values here for in the C column, and let's just do a couple of formatting things. Delete this. Okay, and then let's go ahead and format the C column. Click on the whole C column, and let's format it to be currency. So click on C. All right, so select the whole C column, and then Home tab, Format cells, and we want to do categories currency, 0 decimals with the $sign, right? So same thing we did before. And hit OK. And that should format those numbers to be similar to these numbers. Okay, and scroll down, and to get our next one, go down all the way to C62 and grab the bottom right corner like that and just drag it down to C63. And this is our prediction for the next quarter. Okay, so C63 should say equals 0.9 times B62 plus 0.1 times C62. Okay, so alpha times the last observation plus 1 minus alpha times the last forecast. And double check now that your value for C63 is this. So if you got this in C63, it should say 4,562. Okay, so do we everyone has that? Okay. All right. Next thing we're going to do is calculate the AP again, and then get the MAP, and then we'll compare it to what the Holtz-Winters method did. And you could probably guess that because this did not incorporate the seasonal pattern, that the Holtz method is going to be better, or it's I guess the Holtz Winters is the same as Winters. So depending on the textbook or the reference, the method's either called Holtz Winters or Winters. So I don't know. Sometimes it's just Winters, and sometimes it's Holt Winters, but same concept as we're incorporating the trend and the seasonal pattern. Okay, so in D3 equals, okay, so equals ABS B3 minus C3 divided by B3. Okay, so there's our formula equals ABS double parenthesis B3 minus C3 parenthesis divided by B3 close parentheses. So again, actual minus prediction divided by actual, and you should get 23.26% right there. And if you got that in that formula, let's just apply it to all the other ones. So click on D3 and grab the bottom right corner and let's drag it all the way down to D62. Okay, so you got your APs in this range. And what I want to do is get the MAP, which is the average of the APs, and compare it to the MAP. So we can see they look pretty high. But let's see what the average one is. So I made a little spot here to put the MAP. So in D72, the formula is equals. Okay, average D2 to D62. Enter, and there's our average MAP. So you should get 10.32% in D72. Okay, so all right, so did we get that 10.32%? Perfect. Okay, so what we're going to do now is we're going to compare what the simple exponential smoothing method did with what you can do with the winters, which is going to get the trend and the seasonal pattern, and we're going to see which one has the lower MAP, and use which one we should get for the predictions. Okay, so we did this simple exponential smoothing, and we calculated an MAP of 10.32%. So on average, the forecast was about 10% off. Now, I did this Winters method in the RStudio software. We're not going to do it here because you need an add-in package. But these are the forecasts from that for the next 8 quarters, 2 years. And this is the MAP for that one. So you can see that this one is like, it's way better. This one was about 10% off. This one was only about 5% off. So clearly the Winters method captures the historical seasonal data better, and that's the one we should use. So given this MAP and this one's way lower, and we wouldn't use this method. We'd use this one, and so our forecast would be these values here. Okay, so I'd like to now show you how we can kind of see them visually. So if we can add the simple exponential smoothing to the graph, and then also add the forecast for the winters, we can see the difference. And you can see that your forecasts make a lot of sense when you compare them to the historical data. All right, so we're going to add the two series to the original graph. Okay, so step 5, let's add the Holtz winters. Well, let's add both. We're going to add the simple one, so you can see the difference, and then we'll also add the winter's forecast, which you'll see it kind of incorporates the upward trend and the fluctuations for the seasonal pattern. Okay, so we got your graph here, right? Right-click it, select data. Okay, so we're doing this again. Hit the Add button here. And first series name, click on that button, is alpha equals 0.9 or C1, and then hit that button. And the series values, hit that button, are C2 to C70. Okay, then hit that button to choose it, and then hit, so our series name is C1, and our new series values are C2 to C70. Hit OK, and hit OK. Okay, so it should add that red line there to the graph. Yeah. And we're also going to add the winters method just to see how the seasonal thing does the forecast. So let's go ahead and click on the chart again and right click it, select data, hit this add button again. And the series name for this one is that column, Holtz Winters or E1. Choose that. And the series values, hit this button, are E2 to E70. So E2 to E70. Okay, so for this series, the name is E1, and then values are E2 to E70. And if we hit the OK button and the OK button, oh yeah, so we get it. And then last thing, and we'll double check if we need to repeat any of these steps. You can add a legend. Click on the chart and click on the plus sign and just choose that option for legend. Okay, and to do the legend from the drop down, you could just do uh, click on the chart and chart design and add chart element, and then you can get the legend that way. Okay, so what you should have here is if you're able to get the chart is we've got the sales data here. We've got the quarters. The blue line, if you did the legend, is the sales data, right? Which has a seasonal pattern and an upward trend. Okay, this would be our simple exponential smoothing. And you can see how the Holtz Winters, all right, this is our forecast for the next uh, 2 years or 8 quarters, either same thing. So see how it stays up in the hotter months, it goes down in the winter months, and kind of keeps that upward trend. So it almost looks like if your blue line continued, that's kind of what your forecast would look like. So see how that green line makes a lot of sense, right? So it looks like, we don't know for sure. Something could happen, but that looks like a pretty good predictor of what's happened in the blue data, given that what we think is going to happen, keeping the upward trend and the seasonal pattern. So see how our forecast keeps that seasonal pattern. Okay, so any problems getting the chart like this?
Yes, I had problems trying to get the right uh data, the series values.
Oh, okay. Yeah, let's see if we can do that again. Uh, all right, so you got your original chart with the sales data, yeah?
Yes.
Okay, and then we're going to add the two things to it. So we're going to let's first add the C column, which is the simple exponential smoothing. So click on that, or right click your chart and hit select data. Okay, that should take you to this select data source thing. Yeah, and you're gonna
Yes.
yep, and so we're gonna add the first one. So click on this add button here.
I'm on the ad series right
Oh,
now.
okay, you're here.
Yeah, I'm there. It won't let me click OK. It says something's wrong with it. That's why.
Oh, okay. Well, so your series name you hit the button and you chose C1,
C1, yes.
and the series values you hit this and you chose C1 or sorry C2. C2 to C70?
Yes, I did.
All right, and so when you click it up, open it up, it says series name C1 and then series value C2 to C70.
Yes, it says, yeah, data. Yeah, it says
Oh,
that.
hey, you can't hit OK.
It said, but it keeps going to 71. I haven't gone down to 71.
Oh,
It keeps like I go from C 72 to C 70.
well, you can just change it right here. If you click on the series
Yeah,
values, just hit backspace and change it to
and
70.
70.
Yeah,
Okay.
yeah, you can type it in manually as well.
Okay.
So now it says C1 here and C2 to C70 here.
Yes.
All right, then can you hit OK
Yeah.
and hit OK again?
Yep, I got it.
Okay, so
Thank
that's
you.
the red line, and then let's add the other one. So uh, do the same. So uh, right click the chart. Okay, select data again, and let's hit that add button again. So we're here to the edit series. And this one, this series name, hit the button is E1. Choose that, and the series values are E2, E2 to E70. Okay, and then hit that. So before you hit OK, double check that this is E1 and this is E2 to E7. So is that what you got there?
Yes, E2 to E. Um, I have this weird, strange thing. It says 1 on it. Like it has a 1 before data.
I don't think that matters, but as long as,
Okay, well it does because I tried to click OK and it won't go. So I just delete it.
yeah, just try that. Yeah, so just go back to your edit series box and just whatever that one is, just delete it, and so it should look like this.
Yeah, now it worked now. Yeah,
Oh, okay.
I got it.
And then you hit OK and it worked.
Yep,
All right, and then the next thing is, are you using a Mac or a Windows?
Windows.
Oh, okay, so just click on the plus sign. Oops. Click on the plus sign.
And pick trend line.
No, you want to do legend. Yeah,
Oh, legend.
yeah.
Got
So
it.
legend should have the titles like this. Okay, so
Uh,
you see the blue line is sales, the red line is alpha equals 0.9, and the green line is the winters.
yeah, but the green line's not going on for me. So or add chart element and then trend legend. And then you said it bottom? Are we doing it on the bottom?
Oh, I just chose the default, but the default you can choose either whatever one you want. I chose right, but
Okay,
it doesn't. Yeah, you can choose whichever position you want, but I just chose right because that was the default, I think.
got it.
But either one is anywhere you want to put it is fine. But you got the legend.
Yes,
Okay.
got it. Thank you.
All right. You're welcome. Okay. Okay. Um, everyone else good on the graph here? We got the actual data, the simple exponential smoothing, the red line, and then you can see the nice forecast, the green line, which is the Holtz winters. Okay, which again, the point of this is you would use this method, the winters, if your data has a trend, we have an upward trend, and a seasonal pattern, and we have a seasonal pattern. So we use both those aspects from the historical data to get the best forecast we can, right? Okay, so example 14.8, we're done with that. Okay, so if everyone's good with this one, go ahead and save it. And this goes in the same discussion forum. Okay, so this one's example 14.8, so you can put both of those. You can reply to your original post with the second file, or you can make two posts, but both of those go in here. Okay, the pharmaceutical sales and the soft drink sales go there. Okay, so I think that's it for this one. And again, some of these forecasting methods are kind of beyond what you normally use in Excel for business. But if you're interested in any of these methods or any other forecasting methods like the Holtz method or the Winters method, and want to do any you know uh, forecasting or analysis, I've taught classes on this, and I can show you. If you're interested, you can let me know. But if not, no big deal. Okay, I think that's it for today. And yeah, so those ones. So make sure you get. If you haven't posted these ones are due today. Example 14.2, 14.3, 14.4, and this one 14.5, 14.6. So those are due today. This one we just completed, due next Monday, and we'll do something a little bit different. I think you'll like it. On Wednesday, we're going to apply some of the techniques and forecasts we've learned to do a little simple stock market forecasting assignment. Okay, so that's on Wednesday, something a little bit different. I think usually students like this because they get to do something a little bit different. But yeah, that's it for today, and I'll see you all on Wednesday morning. And thanks for joining, and have a good rest of your week.
Thank you.
Thank you.